In this video, we'll scratch the function f of x equals 3 over 1 plus 2 times e to the negative x by finding its intercepts, asymptotes, the first and the second derivatives, critical values, and inflection points. Let's start with the intercepts. We know to find the x-intercept, you need to make y equal to 0. So we have 3 over 1 plus 2 times e to the negative x equal to 0. This equation has no solution. That means f does not have any x-intercept. Now let's work on the y-intercept. So to find y-intercept, we need to make x equal to 0. So find f of 0 here. We have 3 over 1 plus 2 times e to the negative 0. And e to the 0 is 1. So that's 3 over 1 plus 2, right, which is 1. So the y-intercept is 0, 1. Now let's work on the asymptotes. Let's start with the vertical asymptotes. A vertical asymptote takes place when the function is not defined. So we will find where f of x is not defined. Well, which is when the denominator here equals to 0. That's the only restriction that could be. So when will 1 plus e to the negative x equal to 0? Which means when will e to the negative x equal to negative 1/2? The answer is never, because e to the negative x will always be positive. It can never be negative. So that means there are no vertical asymptotes. Now let's work on the horizontal asymptotes. So we'll take the limit of the function as x goes to negative infinity and as x goes to infinity. So first, when x goes to the negative infinity, let's see. So that means negative x will go to the infinity, and e to the negative x will also go to infinity. That means the whole denominator will go to infinity, so that goes to 0, right? The whole function goes to 0 as x goes to negative infinity. Now let's see what is the limit of this function as x goes to infinity. As x goes to the infinity, negative x goes to negative infinity. So e to the negative x goes to 0, right? Then we have 3 over 1, which is 3. So here, for this function, we will have two horizontal asymptote. One is y equal to 0 as x goes to negative infinity, and the other one is y equals 3 that happens as x goes to infinity. Now let's work on the first derivative and the second derivative of function f. So starting from the first derivative of f, so that will give you, we will see it as 3 times 1 plus 2 times e to the negative x to the negative 1, right? So that will be negative 3 over 1 plus 2 times e to the negative x to the second power, because the exponent is negative 2 now, and then times the derivative of this part, right? So that's 2 times e to the negative x, but we're not over, then times the derivative of negative x, which is negative 1. Okay, that will give us 6 times e to the negative x over 1 plus 2 times e to the negative x squared. All right, now let's work on the second derivative of f. So let's take the derivative of the first derivative of f of x. So quotient rule, right? So that will be the derivative of 6 to the times e to the negative x, the derivative of that, times the denominator minus 6 times e to the negative x times the derivative of the bottom. So times 2 times 1 plus 2 e to the negative x. Now take the derivative of the, I'll do that in the next step. Take the derivative of this part. Okay, all divided by the bottom squared. So this to the 4th power. All right. Okay. Should fast forward this part. This is 6 times e to the negative x. Then take the derivative of negative x. So negative of. Now take the derivative of this part. That is 2 times e to the negative x, then times negative 1, chain rule. All over 1 plus 2 times e to the negative x to the 4th. I know it's tedious. We can cancel out one of the 1 plus 2 e to the negative x to so this becomes 3, this becomes 1, and that is gone. So then let's simplify this part. And we got this. I would like to factor out the negative 6e to the negative x. On top, you have 1 plus 2 times e to the negative x minus 4e to the negative x. All right, all over the bottom. Okay, almost there. Simplify this a little bit. Whew, okay, this is our final answer for the second derivative of f. Okay, there we found them. Now we will use the first derivative and the second derivative of f to find the critical values and inflection points. So start with critical values. So critical values happens when the first derivative of f equals 0, and if you look at the first derivative of f, the top is always positive and the bottom is always positive, so it will never equal 0. Actually, the first derivative of fx is always positive. That means this function is increasing the whole time, right? It will not go down. There's no critical values. So the function f is an increasing function. So is an increasing function. It's increasing in its domain without ever going down, right? It's always going up. Okay, now let's look at the inflection points. And the inflection points happens when the second derivative of f equals 0. So let's see, that means 6 times e to the negative x to, well, the whole thing is equal to 0. Okay, so that means the top, the numerator, is equal to 0. Either e to the negative x is 0, which never happens, or 2 times e to the negative x minus 1 equals 0. That means e to the negative x equals 1/2. So that means e to the x equals 2. So x is ln of 2. So we have an inflection point. Happens when x is equal to ln of 2. What about y? So let's plug in x into, plug in ln of 2 into function f. What is function f again? There it is. It is 3/1 plus 2 times e to the negative ln of 2. Okay, so what is that? 3/, okay. So that's 1 plus 2 times 1/e to the ln of 2. We know e to the ln of 2 is just 2, so that's 2 times 1/2. That's 1, so 3/2. That will be the y coordinate for the inflection point. Okay, so where is the inflection point? I will write it over here. There's one of them. That's ln of 2, 3/2. Okay, we know at the inflection point, the graph changed from concave upward to concave downwards, or the other way around. So let's see which side is concave upwards and which side is concave downward. So ln of 2 is separating the whole number line into 2 intervals. One is from negative infinity to ln of 2. The other one's from ln of 2 to infinity. So here I will pick, in this interval, I'll pick 0. And for this section, I will pick, because 0 is ln of 1, right? That's less than ln of 2. And here I will pick ln of e, which is 1. Well, ln of e is greater than ln of 2, because ln of e is ln of 2.7 something, right? That's greater than ln of 2. Okay, so my test points are 0 and 1 for those two intervals. So now, test point. Okay, I want to check if these test point is making the second derivative of f positive or negative, basically the sign of second derivative of f. Okay, so plug in 0 into the second derivative of f. What is it again? Let me recall. That is 6 times e to the negative x. I'll rewrite it over here. Such a long one, isn't it? 1 plus 2 times e to the negative x cubed. Okay. So if you plug in 0 here, that's 6 times e to the 0 is 1. Times 2 times 1 minus 1 over 1 plus 2 cubed. So I don't care what it is, but I can see it's a positive number. It's positive. Now let's plug in 1 into second derivative of f. You will have 6 times e to the negative 1, so 1 over e, times 2 times 1 over e, minus 1 over 1 plus 2 times 1 over e cubed. The bottom is positive. This is positive, just over here. That's 2 divided by e minus 1. So e is actually greater than 2. So that's a number that's less than 1. Minus 1 will be negative. So overall, it's negative. Okay. All right. So that means our graph will concave upward at the interval of negative infinity to ln of 2 and concave downward at the interval from ln of 2 to infinity. All right. Okay, so I think we have a general idea of how the graph look like. Let's just put it into a graph. So we have one y-intercept, so let's graph it. So for our graph, we have one y-intercept. It's at 0, 1. Let's say it's here, 0, 1. Let's say this is 1. And we have 2 horizontal asymptote. We don't have any vertical asymptote. We have 2 horizontal asymptote. One is at y equals 0. And the other one is y equals 3. Okay. So that's 3. That's 3 is here. 1 is here. Okay. Y equals 3. All right. What else do we have? This is a point on the graph. And the graph is increasing the whole time. And it has an inflection point at ln of 2, 3 over 2. So ln of 2, 3 over 2. Let's say ln of 2 is here. 3 over 2 is right in the middle. So it's over here. That's the inflection point. All right. So to the left side, it's concave upward without having a local maximum or local minimum. And to the right is concave downward. So our graph should look like this. All right. So that's the sketch of our graph.